was working here. Oh, here we are. Yeah. Share screen. Okay, so give me 1 second, guys. I'm kind of rusty. Here we are. Yeah. Okay, so let's talk about, just to give you a brief description about programming, okay, and programs basically. So what we have here, guys, is just for the sake of the class, we have 3 main families of programs. Okay, some of them that are called the foundations, or basically also the people call them original programs. We have those that are object-oriented. And we have those applications. Okay, so the original, the foundation, the core programs that basically are the programs in which all these ones are written, okay, are those famous C++, for example, the famous Fortran. Okay, COBOL at the time. You don't hear about that, but remember, guys, these codes here are really line by line. You need to define the variable. You need to define the size of the variable. You need to assign the space on the memory. So this is these programs, C++, Fortran, COBOL, all these programs that are the core programs, okay? Those ones are very tricky, right? I used to program in C++, and I used to have hundreds of pages of code that Matlab is doing in a couple of pages, right? Why? Because the original guys that were programming, they realized, you know what, programming, if we continue doing this programming, we're going to have a very small group of people able to program, right? So what they created is they simply created routines, they put them together, and they create something that is called the object-oriented programs, okay? So object-oriented programs, guys, we have the famous ones, there are tons, Matlab, R, Ox, and name it. Oh, of course, Python. Oops, what do you write Python? Python. You know, Java. You know, Java is a kind of very interesting because Java has a part on the original foundations, and also more and more Java is also a kind of object-oriented. Okay, so it's more structured now. So you can simply use structures, commands, and then they integrate. And applications, guys, are simply programs that you simply click, and then you get the results, okay? SAS is a mixture of, I would say SAS is also around here. No, but it's also an application, so you can use SAS just to do a small line of commands, and then you get the results. Another one is Stata. No, but also Stata, you can also do some programming. Then you have here, someone mentioned eViews. And what is interesting, guys, eViews also can be, you can code in eViews. It's very complex. It is amazingly complex to, just believe, do you remember, you know, those of you who have had a class in econometrics with me, financial econometrics with me, we use eViews just to do this quick. If you want to program in eViews, it's a nightmare. So the way eViews have been thought is completely different than any of these programs. So just trying to learn how to program in eViews is one semester. It's kind of tough, and it's not worth, I think. Okay, so why it is called object-oriented, I'm sorry. And we're gonna focus on these two guys. So what we're going to have, guys, is a modular way of programming. So what we're going to be creating is files, okay, programs, .r or .m. So .r is the R code, and .m is the Matlab code. Okay? And what we write here, guys, are simply routines. Okay? And the collection of routines create a program. So if we have routine 1, routine 2, etc., the collection of these ones here create a program. Okay, so steps, what I want to do. This is a program. And what is interesting about object-oriented, guys, is that one program can call another program. So let's say this is program 1, can call program 2. Program 2 can call program 3. Program 3 can call program 4 and program 5. and program 5 can call program 2, etc. Do you see? So it is a beautiful way of programming that you create independent modules that do a specific work, and then you can call these modules, these programs from other programs. At the end of the day, you have a very elegant structure. Right? My programs normally, guys, I will show you programs later. My mother programs or the hardcore programs, basically 10 lines. Okay, I tell what to do, what to do, what to do, what to do. But then if you go into each particular code, so you can find tens of codes that are tens of programs that are called by different programs. So that's the beauty about this object-oriented. So you create something, you have the routines, you have a collection of routines, you have a program, and the programs can be called between each other. Okay, so that's what we are going to start learning now. Questions, guys? I think that we are ready to go to Matlab now. No questions? Okay, so can you open Matlab? Please let me share my Matlab. Where's Matlab? Just open your Matlab, guys. Do you see my Matlab? Yep, perfect. Okay, so this is the space of Matlab, guys. You have all your archives are here, your directory is here. This is the part in which we are going to code. This is where we create our codes. So for example, this is one program that I have here. I will show you this in detail later, but this is the way the programs look, okay? And if you take a look, the name of the program is this one here, okay? It's base, simple, B3, whatever, .m. So this is my Matlab code, and you can have different programs all together. So we're going to arrive to this type of programs, guys. But at the beginning, what we are going to use is this one here. It's my command window. You see this part here? You can, of course, arrange the windows as you want, but for now, guys, let's have this space, the larger space of all of them. Okay, here we're going to have our data. You're going to see later. So all the data we're going to be using is going to be moving here. Now, when you have when you go to what we are going to start working is, if you just explore here, this is home. Here's when you want to create a new program, when you want to open a new program, when you want to find files. This is the look for files. And then we are going to use all of these commands later. Okay, we can do plots, we can have apps. This is very interesting with Matlab, we're going to have at the end. But the one that we're going to be using a lot is this editor. Okay, the editor is the one that allows us to basically find positions, find commands, comment the variables, the lines. I will explain this in a minute, and then you can run your programs. You can run only a part of your program, and then you can do debugging, so you can start testing. Okay, so all this part here, guys, we're gonna learn by doing. Okay, now Matlab, as any other program, what you need to have is a store of value. That's what is called a variable. Right? So what is this variable? Any name. So let's do one very simple example. Let's do apples. So for me, apple is going to be equal to, so units of apples. Apples equals 5, or apples. Let's do like an S equals 5. Okay. So what I've done here, guys, now apples is storing the value number 5. Right? So if you don't want, have you realized when I don't write semicolon here, Matlab is going to print what you have written here. So this is what Matlab is understanding. Okay, apples for me is going to have a value 5. But if you do a big program, guys, that does a lot of iterations, you don't want to be printing every single line. You know why? Because the RAM memory is going to simply disappear very quickly. Got it? The way you tell, so let's call this apples, bananas. Okay, so let's do bananas equals 3. The way you tell Matlab, okay, Matlab, I know what I'm doing. You don't need to show this to me. You simply write at the end semicolon. Take a look to what happens. You see? It is there. It is in memory. I will show you how to do that. Let's add another one. So let's talk perhaps rice. And let's take our rice and let's put rice equals 7. right? So what I'm doing is I'm assigning values into variables. Now, if you want to see what you have, you just write who, just type who, and appears the variables that you have active. Okay, so who tells you, oh, you have in active now in your command window, you have apples, bananas, and rice. Now you want to have more information. Well, yeah, but what is that? They are numeric, they are characters, they are strings. What are they? So what you do is you simply write whose. So let me move this somewhere here. Do you see that? Whose? Whose, what it creates is it tells you, oh, you know what? You have apples. Now, Matlab, guys, is a mathematical program. So it always talks in terms of matrices. Okay, so remember, matrices has rows and columns. Got it? So this is what it's telling to you. So this is a 1 by 1 is a scalar, it's a number. Do you agree? How many bytes? Well, 8 bytes. And double, guys, means it's an integer. Okay, double precision simply means double precision. It's simply very precise. It rounds up to the 18th decimal, something like that. Got it? And then you can see apples, bananas, and rice. But you know what is interesting here is you see the characteristics of the variable, but you don't know the value of the variable. Well, if I want to see the variable, for example, bananas, you simply type bananas, and then you have the value. Got it? So, for example, you want to see, yes.
What would like a non-integer look like within the class column?
A character, for example. So if you have a string, is what it will appear a string. Okay, we're going to do that. We are going to write that right. So now imagine that you want to create a basket, and the basket is simply the sum of all these ones here. So it's the sum of apples plus bananas, bananas plus what's the one? Plus rice. So I don't know, perhaps these are kilos. Okay, so your basket is made of 15 kilos or pounds. Yes, you use pounds. Make sense? So now you have what is interesting, guys, is that now you have variables, and with variables you can do whatever you want. You can multiply them, you can sum them, of course, something that makes sense. Okay, and that's what you do. Can you please try to do this with me? Okay, just try to do this in Matlab with me, because it is better if you try to do it, and if you make mistakes, you tell me immediately, because at the beginning it's very hard. You're going to make a lot of mistakes, and sometimes remember, for example, that in Matlab or R, caps is completely different. So if I write bananas with a caps B, it's completely different than write bananas with all small caps. Right? So they are different. And you copy this, and then let's start talking. Do this up to here, and then we can do different stuff now. Okay, we'll say apple price. Banana price. And rice price. Let's say, yeah. So what I'm doing now is I'm assigning, remember I was telling to you that apples, bananas are pounds, for example. Okay, now I'm telling to you, you know what, this is the apple price per pound, $3. The banana price per pound, $1. And the rice price per pound, $5. So now what I need to do for you is how much money you're going to pay. Okay, just do very simple example. And let's call this variable total payment, something like that. How much you're going to pay? Okay, you tell me what is your result.
53.
53, guys, you get that? Okay, I need everyone to be sure that you do that. Okay, so it's going to be apples times apple price plus bananas times banana price plus rice times rice price. Do you agree, guys? And then you get your 53. Now, what happens, guys, very quickly, what happens if the price of rice changes to 7? What is the impact of on your payment? Okay. So the price of rice goes up to 7. So what is the impact on your payment? So how much money you want to pay? So the only thing that you need to change, guys, oh yes, you use the arrows. You see the up arrows, down arrows, you see that? So the arrow up goes up in the command list. So if I click up, what I need to change is what? Is this part here, do you agree? And the only one that I need to change is this 1 to 7. Agree with me, guys? Okay, just change this one here, and then you click, select again the formula, and then you get it. Make sense to that?
Sorry, Professor, can you repeat how you get the list?
Yes, so just the up arrow, you know the arrow that you have in your keyboard. Okay, just you are here in this part here, and then just do up arrow. You see that?
Yeah, thank you.
Yes. Or you know, if you have a huge list, you just type. Let me, for example, apples, APL, and then you simply click up arrow, and it's going to select the one that looks very similar to this one here. This is smart, right? Got it? Okay, so now let's go and let's take a look to what happens to some small words. CD. What is CD? What it tells you is where are you located now. Okay, so if you want to see where are you, you simply type CD, and then it's going to tell you the directory. Normally, guys, what you need to try to do is try to create your you know, I always, well, not this one here, but I create a directory for where I want to work. Okay, so for example, indeed, I want to do CD. Where I work is, so let me find, yeah, this one here. Oops. Now what? So what I normally do, guys, is the following. So you simply click here. You have all this part here. You see, uses Aaron Heap courses 2001 programming. So you go here and you do CD, the tool. And then perhaps I can do prog. And then I can do, we can call them progs. You have Matlab files. I think I have that already. Yeah. So this is the one. You see, this one here, guys, is where you want to put all your programs. You know, just create something special for this class. So you're going to be storing a lot of programs, code, etc. So this is up to you. So this is where I want to be working. Oh, what's going on? Oh. Oh, yes. I have two of these. Okay. It's only one. R, guys, uses the opposite. Uses instead of this backslash, the other slash, this way. Yeah, this is one of the differences in R and Matlab. Okay, so now if you want to see where are you, just type CD, and then you see you are there. Got it? And normally this is going to stay here until you change it. So if you close Matlab now, open Matlab later, this is going to be the directory that you're going to be working with. So that's very practical. So you're not going to be saving somewhere that you won't remember later. Just create a file, a directory, and then just put everything there. Make sense? So now what we can do is, for example, let's save what we have done up to now. So I save example 1.m, for example, .mat, sorry, because this is a, I want to save what we have done up to now. Right, so the exam1.mat, the exam1 is simply, example one, simply a name. It's any name, I just put it example one. So what I have done, guys, is I have saved all the things that I have done up to now, right? Now, if I want to recover what I have done, I simply do load, and then you type example1.mat, and then you do a whos. Well, I'm repeating all this stuff here, and then I have it here. Okay, so I retrieve the things that I have, and I want to see, for example, Apple price. Oh, sorry. I just want to see the Apple price. 3. You see? So you recover. So you save all your work with save and a name. And I can do that, guys, and I know where I'm saving because I already defined my directory. So this is going to be my working directory. Okay? When you recover, you simply say load, and then you recover. Now, if you don't have, if you're saving somewhere else, what you need to do is, if you want to save, what you do is, I want to save, for example, in a specific directory. Okay, so what you do is you simply copy all this part here. If you want to save somewhere. And then you simply write the name in between, inside here. The name of the file. You see? So what I'm telling here you can change whatever you want. So if you want to save this in a specific place, what you do is, okay, change the directory, and then the last part is the name of your file. Right? When you load, you do exactly the same. So instead of save, you do load all this part here. Make sense to you guys? Yes, Kevin.
Professor, can you clarify the difference between a .m file and a .mat file? Because it seems like
yes,
one of them is one object.
No. Yes, .m file is a code, is a program. This is a program. This one here is a line of commands. Remember, if you have a list of let me move. Come on. Yes, this is a program. This is a .m. You see, it's just lines of code. Do this, do this, do this, etc. This is .m, a program and a script of Matlab. And that .mat, it can contain everything. It can contain code, can contain data, can contain everything. So you put everything that you have in your working space in a single program, right? Make sense to you guys? So let me escape here. Make sense? Okay, so now I think that we can do some other stuff. Now, if I want, for example, you know that if you do the who, now these are the variables that I have. I want to remove one of them. Okay, which one do you want to remove? Apples, for example. Let's remove apples. So let's do, if you want to remove one, you simply do clear and the variable name. Then do your who, apples disappear. So if you want to do more, you simply do a name, space, name, space, name, space. The ones that you want to clean, you simply clean them. Now, guys, this looks, you know, why I'm cleaning this one here. Sometimes, guys, when you have huge data sets, you don't want to keep everything in memory, okay? Because memory, if you know, the data occupies memory. So once you use the data set, one data set, and you're not going to use it again, better to clean it, clear it. It makes sense to you? So you're going to clear memory, okay? And then you simply do clear, and then you separate whatever you want. Now, if I want to create my apples again, just to continue with my example, I will recreate that apples. Okay, here we go. Okay, just to have all my variables. Now, there is something very important, guys. Sometimes when you run a program, and you want to see that, sometimes you enter into a loop that you did something wrong, and your loop is going to be infinite. So you are never going to exit the loop. So, and then you wait 1 hour and continues working and say, well, what? That's strange. It should have lasted 1 second. It's 1 hour, 2 hours, and the machine starts burning. So how do I stop the Matlab? Of course, one way of doing that is simply click the X. And the other way of exiting, guys, is you simply press Control at the same time plus C. Okay, so you don't write Control C. What I'm saying, I'm writing. You click Control and the keyboard C, Control C at the same time. All right, with that, Matlab is going to stop. It's going to stop whatever it is doing. And this is going to, it is a useful command because you see sometimes it's weird. Now, if you want to quit Matlab, yeah, you know, yeah, you just click the X or you just write quit. It's up to you. Got it? Matlab, guys, has a tons of you know, typical, you know, you can do 2 plus 5, you can do 4 to the power 3 or to the power 5. You can do the common commands, for example, absolute value of -9, you know? So these are the commands. So let's review some of them. Absolute value, ceiling of 3.1. Ceiling, guys, remember, it goes to the next integer. Okay, floor, so the other ones that we use of 3.1, 3. You see, round of 3.1, 3. You see, what else do we have? Log, let's say log of 3, exponent, etc. I think that this should be, what else can I have? Oh yeah, another one that we're going to use a lot, sine. So what is the sign of -3? Appears -1, okay? This -1 means that the sign is negative. So if you do sine of 3, it will appear 1. Make sense? Okay, we are going to use that later, guys. Of course, we have, for example, we have sine of 60. You know, we have a cosine of 60. Oh, sorry. You have a tangent of 60, etc. So all the trigonometric functions are going to be there. It's very common. Okay. So let me share this one here. Okay, guys, can you please create, let's say, create 3 variables, x, y, and z, okay? Let's start this with 5, 3, -2. And what I want is to create the variable c, that is going to be equal to 3x plus 2y minus z. Just very simple stuff. Okay, so this is 1. Oh.
Professor, are we declaring this in a Matlab file, which is in an environment? It's fine.
No, it's just in the command line at this point.
Okay.
We are going to do programs later, but at this point, simply use what we are using, commands. I want you to be, feel confident about this stuff, and later programs are going to be extremely simple. Over 2, 8. So I want you to create x1 is going to be the -1, and I want you to call x2 for the positive side. So when I say negative is this minus here, and when I say positive is this positive here. Okay, can you solve this equation? Minutes, guys. No, give me 1 minute. We'll bring someone. Okay, guys, let's do it. Okay, how do you feel? Comfortable? Okay, so let's define, I will define all the variables. X equals, so I copy it here. I can define them in a single line, of course, it's easier. 5, later we're going to learn how to define this in a matrix form, okay? But at this point, y equals 3 and z equals -1. Okay, and then what I want is to compute c. That is going to be simply.
Professor, we can't see anything.
Oh, you don't see? Perhaps I can erase this one.
You're still stuck on the whiteboard.
Oh, got it, got it. I understand what's going on. Yep. Now do you see that? Okay, so I define my x equals 5, my y equals 3, my c equals -1, and c3. Perhaps I can 1 second. Just to make it better. You know, perhaps. Kind of. Yeah, you know, there is a way I can increase the size of, I will do this for next class. So now c, guys, is equal to 3 times x plus 2 times y minus z, correct? This is the way it works. It's a common equation. So c is going to be 3 times x plus 2 times y minus z. And then you have defined already the values up front. So that's the way it works, guys. When you do a program, what you can do is first the math in letters, and then you can enter data. But at this point, we enter data, and then we get a model. And here we have my, I'm sorry, YAC. So now I can take a look to see. You see that? 22, do you get 22? Guys, do you get 22? Did you get 22? So x equals 5, y equals 3. Yeah. Wait a second. So I think I made a mistake here. And then c. No, that's okay. So y equals 3 and c equals -1. Oh, sorry, c was -2. So my wrong. So now I can take a look to see. 23? Yes, 23. Everyone, 23? Yep.
Yep.
Excellent. Okay, so you see data. So first variable, you assign the values to each variable. Once you have the variables with values, then you can do whatever you want. Okay, we are of course in a very simple definition of variables, but later we're going to complicate our life with matrices, vectors, etc. Now, the other question, guys, was the quadratic solution. Remember? So it has a formula, and I told you I want x1 to be the negative side. So it's going to be equals to my. Sorry, I think I made a mistake. It's minus b. So it should be. Okay, we'll do parentheses minus b. Let's go back to my share. Oh yeah, I put it is correct. So which one is A, B, and C? This one here, guys, is A. This one is B, and this one is C. Okay. So that's the way it works: A, B, and C. So we simply replace the values in our formula. So x is going to be minus b. B equals 2. Agree? Minus square root. I always forget this is QRT, I think. Square root of minus 2 squared minus 4 times a plus times b, but b equals -4. Okay, and all this divided by 2 times a, and a equals 3. Guys, you agree with me? So it is minus b minus a square root of b squared minus 4 times a times b. All this divided by 2 times a. Sounds good or not? Guys, sounds good? So I obtain minus 1.5352. Someone to corroborate? You get it? You need to do this, guys. Otherwise, you know, you're gonna get lost very quickly. Do it. Otherwise, you're going to get lost here, guys. Now, the positive side, you simply click up, change the x1 for x2. And then instead of minus here, you simply write the plus. And then you click, and then you obtain these values. So these are the two values, guys, that make my equation equal to 0. Can you verify just with x2? Can you verify that indeed your quadratic equation equals 0 when x equals 0.8685? So what I'm telling to you is, can you please use this equation here? Okay, use this equation here. Replace x by the variable that we have found and show me that this is indeed equal to 0. Do you understand? Okay. Just with one of them, 0.86. I don't want you to type 0.8685. I want you to use these values here. So you can call it test, something like that. And test needs to be 0, right? If my solution is correct, test should be equal to 0, must be equal to 0. So the equation is 3x squared plus 2x minus 4. And you need to show me that this is indeed equal to 0. Ready? You tested equals 0? Yep. So okay, so let's do this. It's going to be 3 times. I don't want to write this number. I want to use x2 because that's a beauty about Matlab is 3 times x2 plus 2 times x2 minus 4, right? This is my equation, right? Then if you click enter, oops, what happened?
Yeah, Professor, it is 3 times x2 squared, and then you
Oh, yes.
parentheses around the x2.
Yes, completely right. So this one here is a square. 0. Do you agree? Guys, do you follow what I've done? I have used simply the equation, replace the values that I have found, and then it needs to be 0 because that was the definition of my variable, of my quadratic. This one here. You see? Now, can you do this very quickly using x1? That also satisfies, this equation is satisfied also by x1 in less than 1 second, guys. You can do that. Not 1 second, let's say 5 seconds. Done? Guys, the only way to do that, up arrow, and then instead of x2, you use x1, right? All the remaining part is exactly the same, just x1, and that's it. That's the beauty about variables, guys. So they store values and you simply replace the names and then you run immediately. Questions? Make sense? Okay, so now let's do, something that sometimes we need help. And perhaps you want to understand how SQRT works. You simply type help SQRT, and then appears the definition of how the variable is used, when do you use it, etc. Now, there are sometimes, guys, that you don't remember exactly what command. You say, I really don't know exactly what I'm looking for, but let's say I'm looking for complex something. Okay, exists a command that is called look for, and you just do complex. And here be ready to apply the Control C, because complexes will appear in hundreds of programs and we will start running. And then Control C will stop the program. Okay, so look for, and some clue for Matlab. Matlab is going to try to find something that looks like complex. Right? So just click enter and it starts moving. You see? Moving, and it can continue for a long time. So let's stop, Control C, stopped. Have you done that? Got it? Make sense, guys? Do you understand? So now let's start working with arrays. And let's do a very silly way of doing an array. So imagine, guys, that you want X, okay? And the way you create a vector in Matlab is something like that. Let's do a 0, and then I want to increase in 0.1 times, 0.1 p. So p, pi, is our famous 3.1416, okay? But in Matlab, the code also in R is pi. I want 0 times 0.1 pi, 0.2 pi, and pi. Okay, can you create this vector of values? So simply type this, 0, 0.1 times, of course, the star, 0.2 times pi, and pi. So what I'm creating is a vector of elements that go 0.1 pi, increments of 0.1, right? Just type this one here, and let's find a couple of functions. I want y to be equal to the sine of x, and c equals to the cosine of x. Okay. So I call this X, and it's going to be bracket, 0, 0.1 times pi. And I will replicate this. So this is going to be 0.2, 0.3, 0.4, 0.5, 0.6, 7, 8, 9, no 1. Do you agree, guys? I need to delete this comma here. So this is what we have. So we are basically creating from 0 to 3.4, 3.1416 the values there, right? And then once you have this variable defined, y equals sine of x is a piece of cake, right? Simply do this. This is the sign evaluated at each value of x. You see the beauty? In a single run, you get 10 values already. Okay, you can do z. I think I call this z as cosine of x, and then you get it. Okay, so when we use this type, this is a function, guys. It's already a pre-built function, and this is an argument. So how do we read this in mathematical ways? Is please evaluate the sine function in each of the values of x, and x values are 0.0, 0.31 up to 3.14. Make sense? Now, guys, what is the tricky part here? What was the tricky part here? This part here. You agree? So now imagine, guys, I tell you, you know what, guys, I don't want to have only 10 value or observations increasing by 0.1. I want from 0 to pi, but increasing in 0.01. So it will take, you know, at least 1 hour to type these type of things, and you can make mistakes on that. Okay? So that's why we're going to use something that I call sequences. Okay? And one of them, for example, I can write, let's call, Q, and it's going to be equal to, the definition is from increments 2. So what I'm saying here is I want Q to be start at 1, increase by 1, and end in 10. You understand? So this is the sequence. This is the command of the sequence. Is from increase up to. Now it works increasing, but also works decreasing. So if I want to start from 1, decreasing by -1 and 10. Oops. No, sorry, cannot. It's not possible. It should be -10. Got it? Now, if the increase is 1, guys, so this is the default. So what you can do is simply, well, let's do this. If you do this, you forget the middle 1. By default, the increase is going to be by 1. So, however, if you want to do increases in 0.1, for example, that's what you need to do. Got it? Now, make sense? So let me show you something more. And then that's the logic of Matlab and any program. When you have a vector, guys, so I imagine I have my vector x that has certain values. Okay? And then you multiply this one here by something. So imagine you multiply this by 3. So what Matlab does is element by element multiplication. When you have a scalar here, so it's going to multiply this times this times this, etc. And this times this, etc. Make sense to you? That's what it does. So now, guys, what I want from you, you see, you have typed this one here. I want you to create x without writing every single number. So what you do? So you want X to go from what to what, first of all? In my example.
From 0 to
0 to
pi.
pi.
Exactly. So 0, but I need to have the increment here, right? Because it's not going one by one. 0 to pi. Increasing by what? 0.1. Correct? Then I want to register this as a vector, because I need to have a vector to do this stuff. And then I simply multiply these times. No, it's not pi. Sorry, this is 1. I want this to go from 0 to 1, correct? This is 0, 0.1, 0.2, and then I have a 1 here, times pi. So what this will do, it will create first a sequence, and then multiply each of these values times pi. Got it? Can you test that? Once you do that, I want you to compute an x1 that basically I want that is going to be a sequence of 0, 0.01, 0.02, up to 1. The sequence is different. Simply do this times pi. Next. Ready? Guys, there is no other way of learning this stuff than doing it. Okay, if it doesn't work, do it again and just try to find the logic. What is the logic? I don't understand the logic. Do it. So if I call here x, is going to be, I want the vector definition, so that's why I have bracket, bracket. I want this number to go from 0 to 0.1, increasing 0.1 up to 1, correct? So this is going to create a 0, 0.1, 0.2, up to 1. And then I want every element of this one be multiplied by pi, correct? And then simply click enter, and then you have the values. And then you can compute sine of x, cosine of x, etc. Now, if you want to do a more granular value, so you simply, I told you, do this 0.01. Okay, easy. 0.01 times pi, then you have the values. So you have 101 values. Now I want 0.001. Like, you can do that, but I don't want to show that. I will simply do this semicolon. And you simply do it. Piece of cake. In a single line, you can create a vector. And with that vector, guys, you can do whatever you want. Right? So you can find the sign of x now, for example. It will be big. 1001 values. You see? We are going to learn how to graph. We're going to learn a bunch of things, but makes sense to you guys? You understand what we're doing? Okay, variable. We are creating sequences. We're mixing sequences with scalars, and then we can start working with that. Okay, so what I want from you guys is I want to have x1. Well, let's define, yeah, y1. I want this to be 1, 2, let's say up to 10. I want y2 to be equals 101, 102, 110. And I want y3 to be simply equal to y1 plus y2. Can you do this very quickly, please? Ready, guys? Done? Okay, so let's do this. Let me show you. The faster you do it, the better, okay? So what I'm going to define is y1 is going to be a sequence 1 increasing by 1 up to 10, correct? And y2 is going to be, it starts at what, 100? 101, right? 210. And then I want y3 simply equal to y1 plus y2. Do you agree with that, guys? Make sense? Very quickly, very compact. Now, it doesn't matter, guys, if you put, in this case, as soon as you're not doing any mathematical operation, you can use also these ones if you want. But as soon as you're not multiplying by anything, you just simply use the regular one. Make sense? Now, there is another command, guys, that is called Linspace. See, let's call this C. Okay, Linspace is from, up to where, and how many observations. So it is start in 1, finish in 10, and create 10 values. It is different, guys, than saying from 1 to 10, because you don't know how many well, you know. How many values you have when I say 1 to 10? How many values, guys? So let me copy this one here. When we said 1 to 10, where is 1 to 10? This one here. So how many observations do you have there?
10 observations.
10 observations, right? What if I told you, guys, I want from 1 to 10, but I want to have 15 observations? That's tricky, do you agree? Because you need to sum one, the maximum plus one plus the minimum divided by a total number of observations, right? But you need to do that by hand, so I can kind of weird. The best way to do that is basically what you say is C is Linspace 1 to 10, and I want 15 observations. So Matlab is going to define for you the exact interval. Got it? So you just click, here you go. You have 15 observations, and the increase apparently is 0.6429. So you should obtain the same if you do, let's call C1 equals 1, increasing by 1.6429. No, sorry, 0 point. Up to 10. Yeah. It is rounding. So even more, it's bad because I don't arrive to the same number. Got it? So this is the way to do it, guys. So Linspace is a very useful command. It tells you from where to where, how many observations you want to have. Got it? Make sense? So now let's do something that's called array addressing. So let's take a look to how do I define. So let's define X, for example, guys, a simple 1 to 10. So this is my vector X. For example, I'm just interested about position number 4 in my X. Right? So the way, so let's create Y is going to be position. So Y is going to be one variable that is going to take from X the position number 4. You see that? X position number 4. So 1, 2, 3, 4. Selecting this one here and is setting this value into Y. Make sense to you guys? Now I want to create another variable, let's say Y1, that is going to be, basically, it's going to take the last 3 observations of X. How do we do that? Well, perhaps I need something more. Yeah, I need something more from this part here. Okay, the way you address from this point to this point here, remember it's a sequence. So what I want is from observation 8 to observation 10. You agree? So that's the way it works, because remember 8 to 10 implies it's going to be 8, 9, and 10. And it's going to take from X, take positions 8, 9, and 10. Take a look to what happens. Make sense? Now imagine, guys, that you want to take positions 1, 3, 5. So 1, 3, 5, 7, and 9. How do you do that? So let's call this Y2. I want Y2 take the position of X 1, 3, 5, 7, and 9. What sequence do you use? Give me a sequence. Of course, you can do the following. If you want to do this by hand, guys, you need to define a vector inside. Okay, so what here you can write 1, 3, 5, 7, and 9. You can do that. Right? But you know, this is not efficient. Is there a way in which you can create these 1, 3, 5, 7, and 9 using the sequences? Yes or no? Guys?
Yes.
How do you do that?
You're gonna have to declare the length of the array, and then you go from position 1 to the length of the array, and then you stick the number of spaces you want to skip in the middle.
Yes, but in a very easy sequence. We have done with this type of sequence. With this type of sequence, how do I do that? Remember, this is a sequence. Do you agree? Is a sequence increased by how many? When do you start? Guys, always the sequences. You start at 1. That's what I'm saying. Then you increase by what? By 2. and then you end up where? Well, at 9. Agree? So it will create this sequence. It's going to be 1, 3, 5, 7, and 9, exactly what you want. And these are the positions of X, position 1, 3, etc. And then you get it. Make sense? Now, what if, guys, I want to have these numbers, but reversed. I want the 9 to appear first, the 7, the 5, the 3, and the 1. How do you think you can do that? So Y3 in terms of Y2. So what do you do in order to have 9, 7, 5, 3, and 1? So remember, guys, we are talking about two things here, values and positions. Got it? So what we are doing here in this part here, these 8 and 9, guys, are not values, are positions. Do you agree with me? Guys, do you agree? So what I'm telling to you is I want this matrix or this vector to appear in the reverse order. I want 9, 7, 5, 3, and 1. How can you do this with the things that you know up to now? Okay, think a couple of minutes. Just with the things we have done up to now, and I will do some exercises.
Could you use the same formula as for Y2 and just switch the 1 and the 9?
This formula here, or this formula here?
That one. Yeah, that one there.
Yeah. So I changed the 9. What else?
You keep the 2 in the middle and then put the 1 at the end.
Okay. But now remember, this can be possible if and only if. Take a look to what happens. What is the problem with this formula here, guys?
It won't be decreasing, right?
Exactly.
The
So what do you need to
negative.
do? Exactly.
Negative.
Exactly. Okay. Now, what is the issue here, guys? What is the position number 9 in Y2? Y2 only has 5 observations. Do you see that? This was useful if I want to use X. So if you want to use X, that makes sense, correct? Because it will take from X, take positions 9, -2, 7, -2, 5, up to 1. So this is going to do this. You see? Is the reverse of this one here. And if you want to use Y, so let's call this Y4, based on Y2. Remember, how many positions, how many values do I have in Y2? I have only 5 positions. Correct? So this should be what? Where I start? I want to construct Y4 based on Y2. Where do I start? What is my maximum value? So remember, sorry, not maximum value, maximum position. How many positions do I have? 1, 2, 3, 4, and 5, correct? So this should be 5, decreasing by what?
-1.
-1 up to 1. Agree with me or not, guys? Yes or no? This is crucial because we're going to, this is something we're going to be using with huge data set. It doesn't matter. You need to understand this part here. So we do this. Okay, so let me be sure that you understand this part here. Okay, so imagine, okay, I have X, I will just write any number, 3, 4, 7, 12, 15. Okay, this is X. These are the values. Now, positions. This is position number 1, number 2, number 3, number 4, number 5. So these are the positions. Got it? Do you understand what is position and value? So now my question is, okay, guys, how do you build? Just think, don't do this in Matlab. Think, I want Y1 to be equal to 4. I want Y2 using X, okay? I want Y2 to be equal to 3, 7, and 15. I want Y3 to be equal to 7 and 12. Got it? That's what I want. Okay, think and try to do this in Matlab. So remember, guys, these are positions. Okay. How many observations do I have here? I have 5 observations. And then I want y4 to be equal to 15, 12, 7, 4, and 3. Okay, 3 minutes to do this. Do it, because these guys, these games are extremely useful for helping you understand how the things work. Positions and values, positions and values. Ready? So let me take a picture of this so I can do this in Matlab. Okay. So let's go to Matlab, and you help me, okay? I don't do anything unless you tell me. So how do I define x? Well, x is a random number, so I need to enter the values, right? So there is no sequence, nothing. It's simply random values. So I have 3, 4, 7, 12, 15. So this is my x variable. How many observations do I have? 5. Okay. What is the value in position 3?
7.
Right. 15 corresponds to what position?
The 5th position.
Yes, the 5th position. Right? Makes sense? Okay. So how do I select y1 to take the value number 4 using x? What position I need to take from x?
Take the 2nd position.
Agree. Guys, does it make sense to you? So what I'm entering inside the parentheses, the position, it's not the value, it's a position. So I want from x position 2. What is that? Oh, sorry, 4. That's what we want. So if you just type now y1 is 4. Make sense to everyone? So let me type again x just to have it here. My next question is, I want to have y2 is going to be 3, 7, and 15. So it's going to be 3, 7, and 15. So you see, it's jumping 1. So y2 is going to be equal to x. What I take from x? What sequence you can use here?
From going from 1 and then stick a 2 in the middle and then you end at position 5.
Position 5. Right? So if you have a sequence increasing by 1, increasing by 2, increasing by 3, not always, you cannot always use sequences, guys, okay? But if you have a sequence, you use sequences. It's the easy way to do that. Make sense? Now, there is a trick here, guys. You know what? If imagine you don't know how many observations do you have. Instead of using 5, what you can use is end. End is going to be the last position. End is a position. It's not a value. It's a position. Okay, so the next one. The next one is 7 and 12. So what can I do? So this is y3 equals, what is a smart way of saying that? 7 and 12. Well, you can argue, you can say, you know what? I can do positions 3 and 4, right? Oh. Correct? Or if you want, what you can do is, the sequence doesn't matter a lot because it's only one difference, 3 to 4. Now what I want is to revert the positions of, so basically x, again, x, and I want y4 equals simply 15, 12, 7, 4, 3. So how do I do that? Using x. When do you start? 5, or let's do end, right? What else?
5, -1 to start.
Oh, no.
Yeah, sorry. Yeah, no, I didn't. I thought that was an easy recommend. You can use 1, yeah.
Yes. Make sense to everyone? Okay, guys, these stupid things are going to be extremely useful once we work with real data. You're going to see. Make sense to everyone? Okay, so now let's start adding and appending matrices. So let's define A, for example, that is simply, let's say from 1 to 5, okay? And let's say B is going to be from 12, how many? 16. And so we have 2 vectors. And now what I want to do is I want to create C that is simply A together with C. So A first, B next. This is going to be C. So C, guys, if you want to put two vectors together, first of all, the dimensions must align. In this case, this is a 1 times 5, A is a 1 times 5, B is a 1 times 5. So I can put them together. So what I will do is I will create a new vector C that is going to be A, comma, B. When you say comma, guys, you are simply adding to the as a row. Okay, in R, this is called R. Sorry, this is row. No, this is yeah, this is R bind. In R, the command is going to be R bind. I will delete this. Okay. In R, the command is going to be R bind A and B. This is going to be the command that we do in Matlab. In Matlab, we simply put them together. In R, we need to use a command that is called row bind. Put two rows together, A and B. No, sorry, it should not be row. This should be column. Sorry, my mistake. It's column bind. So what we're doing is these columns here and these columns here is column bind, C bind in R. And here you go. You see? So we have put these two things together. So A is going to be this part here. I'm simply joining with B, that is this part here. Make sense? Now, if you want to join one and the other one down below that, you need to be sure, first of all, that the number of rows are exactly the same. In this case, A and B are the same. So D is going to be now A semicolon B. So in that case, guys, you need to be sure that the rows are exactly the same as the rows on the next one.
Professor, just so I get it right, in my head, the second one, D is C bind, right? And then number one is R bind. No, D is R bind, number one C.
This one is R bind.
D is R bind, yeah, because you're binding
R bind.
rows. Yeah.
Exactly. And the other one is column. Don't get confused at this point, guys, but the commands are going to be different names, but the logic is exactly the same. Okay, guys, can you add a new variable A, B, C, D, E? Let's select E to be a variable that goes from 121 to 123. So it's only 3 numbers. Okay, you see it's only 3 numbers. What I want you is I want you to create a new F variable, an F matrix, and it's going to be 0, 0, 121, 122, 123. Just below this one here. So it's going to be like D, and below D is going to have 0, 0, 121, 122, 123. Okay, do it as you want with the things that we have learned up to now. It doesn't matter if it's a very rudimentary process. You find a solution, guys, okay? There is no one solution. You can create whatever solution you want. Ready? So, well, you know what? I can create a vector E1, for example. That is going to be a mixture of 0, 0, and E. What do you think about that? Can be. So what is going to be? E1 is going to be 0, 0, and then that's it. And then after that, it's very simple. ABCD F is going to be simply a combination. I have already D, so I don't need to do anything. I got these two. And below D, I will write E1. Make sense? Okay. Now, there is another command that is really useful, guys. That is called the repmat. So let's do G. So repmat. So this repeats a vector or a matrix, whatever. So what I want to do is I want to add a vector of 9s below this one here. Right? That's what I want. I want to add 9, 9, 9, 9, 9. So what I will do is, okay, what I want to repeat, 9. How many rows? 1. How many columns? 5. So you understand this command? So this says, repeat this part here. How many rows? 1. How many columns? 5. So if you take a look to what happens, G equals 99999. You see that? Now what I want is I can get H is simply going to be equal to, if I want to do this below, it's going to be F semicolon G. Then I have it.
Sir, Professor,
Yes. Yep.
can you repeat what the 1 signifies in the repmat command?
Yes. Where's my repmat here? Oh, here. So this is the value that you want to repeat. This is number of rows. So I want to repeat 1 row. And how many columns? I want to repeat 5 columns. Right? So imagine, guys, that I want you to add 88, 88, 88. So 1 column with full 88s. Can you do that? So what I want to have is, create a new variable, a new vector that is now is going to be a column vector. Okay, 88, 88, 88. So you need to have 4 88s. Once you create these 4 88s, you simply put this together to this matrix. Okay, so remember, guys, that the way you define a row vector is with commas or spaces. 1, 2, 3, 4. It's going to create a row. If you do 1 semicolon, 2 semicolon, 3 semicolon, it's going to create that. Got it? Okay, so you do it. I want the 6th column. I want to be a column of 88s. Ready? Yep. Okay, so I will create I that is going to be equal. I can write, of course, if you want to do this, 88 semicolon, what semicolon here? 88 semicolon 88 colon 88. So that's okay, right? But imagine I told you 1088, so it's going to take a lot of time for you to do that. So instead of that, what I can do is I can use a repmat. Repmat. What I want to repeat, 88. How many rows? 4. How many columns? 1. And then you get it. And then J is going to be basically, I have already created this vector here, a matrix H. And I want to join this with I, correct? So I use comma because I'm doing column, combining columns. Do you agree? So enter, and then you have it. Make sense? Can you please create J1? And the only thing that J1 is going to be doing is this one here. The last column is going to be the first column. The third column is going to be the second column, etc. Okay, before that, guys, okay, copy this one here. Before doing that, I want to give you an additional point of information. Are you with me? So now, guys, for example, you have a matrix. Okay, you have data, and you want to know the dimensions of the data. So what you do is basically you use the command size of J. So size of J is going to tell you how many rows do you have, how many columns do you have. So J is a 4 times 6. This is useful when you have a data set and you want to know how many observations do I have, how many days do I have, how many clients do I have. Okay, so this is size of the variable J. Now, if you just want to know the number of rows, size of J, comma 1. If you want to know the number of columns, size of J, comma 2. Got it? Okay, guys, now you can do what if you try to use this size of J, it's the size command, in order to simply flip up and down. So I want the last column to be the first column, the second, the third one, the second, etc. So basically this one here, I want this to be the last column. Sorry, the last row. Got it? Okay, so do it, guys. So let me write J again, just to... Ready? So let's call K, whatever. So K is going to be J. So we need to reorganize